Hello guys, welcome to my channel. This video covers the basics you need to know about polynomials, what they are, their key parts, and how to find their degree. I will also provide more tips on working with polynomials in future videos. So now let's get started. This is a standard form of polynomial. Polynomials are algebraic expressions that consist of variables, coefficients, and constant numbers, which are combined using only the operations of addition, subtraction, and multiplication. In this expression, 5 and 3 are coefficients, and coefficient is a number which is multiplied by variable, and x and y are variables. And here we have 1 as a constant number and 2 as an exponent. And as you can see in this expression, we have plus and minus as an operation. Remember that polynomials are not allowed to have division operations or negative integer exponents. So this one is a polynomial, but x squared divided by x minus 3 is not, because it involves division. And this expression is a valid polynomial in the variable y, but this one is not a polynomial because it contains a negative exponent minus 2. In polynomials, a term refers to each separate part of the polynomial expression, and it can be a constant or the product of a coefficient and a variable raised to a power. For example, in this polynomial 3x squared minus 2y minus 5, there are 3 terms. Alright, now let's talk about the degree of a polynomial. Basically, it's all about the highest exponent you have got going on in that polynomial expression. So to find the degree of the whole polynomial, you just look for the term with the biggest exponent of the variable, and that's the degree. So, for example, if your polynomial is 5x to the power of 3 plus 2x squared minus x, for the first term, the exponent is 3. And for the next term, the exponent is 2. And finally, for the last term, we consider the exponent to be 1 because there is no exponent shown here. So the term with the highest exponent is 5x to the power of 3, where the exponent is 3, so the degree of this polynomial is 3. But if you don't have any variables at all, like 5 plus 3, in that case we say the degree is 0 because there is no variables with exponent. Now let's take a look at this polynomial, 2x plus 1. What do you think about its degree? Here we have a variable x, and we need to consider its exponent to find out the degree of this polynomial. You need to know that a variable that written without an exponent has degree 1. And for the last term, we have a constant, so the degree of this constant number will be 0. So here the degree of this polynomial is 1. Now let's take a look at this expression. 3xy squared plus 2x squared minus 5x. If you want to calculate the degree of this polynomial, you need to determine the degree of each term and then pick the largest one as the final answer. And as you can see, in the first term, we have 2 variables multiplied by each other. So to calculate the degree of this term, we need to add the exponent of these 2 variables. The exponent of x is 1, and the exponent of y is 2. So the degree of the first term will be 1 plus 2, which is equal to 3. And for the next term, we have 2 as an exponent of x. So the degree of this term will be 2. And the degree of the last term will be 1. So the largest degree among these 3 terms is 3. Therefore, the degree of this polynomial is 3. You need to know that polynomials of degrees 2 are known as quadratic polynomials. And here are some examples of quadratic polynomials. And as you can see, each of these polynomials has the highest degree term with an exponent of 2. And polynomials of degrees 3 are known as cubic polynomials. And here are some examples of cubic polynomials. And each of these polynomials has the highest degree term with an exponent of 3. Now it's time to solve some examples to review what we learned in this video. In these examples, we want to identify the number of variables and terms and then calculate the degree of the polynomial. So we start with this expression, 2x squared minus 8xy the power of 3 minus 10. In this expression, we have two variables, x and y. So the number of variables in this expression will be 2, which are x and y. And in this expression, we have 3 terms. So the number of terms will be 3. And for the degree of this polynomial, we need to identify the degree of each term. So for the first term, the exponent of the variable is 2, so the degree of this term is 2. And for the second term, as you can see, we have two variables multiplied by each other. The exponent of x is 1 and the exponent of y is 3. So to calculate the degree of this term, we need to add these two exponents. So 1 plus 3 equals 4. And the degree of this term will be 4. And the third term is minus 10, which is a constant term, and the degree of this term is 0 because there is no any variable here. So in this example, the degrees of 3 terms are 2, 4, and 0. And the largest degree among these 3 degrees will be 4. So the degree of the polynomial is 4. And now let's take a look at this example. In this example, we have one variable, which is x. So the variable of this polynomial is 1, which is x. And there are 1, 2, 3, and 4 terms. So the number of terms will be 4. And for calculate the degree of the polynomial, we need to calculate the degree of each term and then pick the largest one. So for the first term, the exponent is 6. So the degree of this first term will be 6. And for the next term, the exponent is 5. So the degree will be 5. And the third term, the exponent of the x is 1. So the degree will be 1. And for the last term, because there is no any variable here, the degree of this term will be 0. So for calculate the degree of the polynomial, we need to pick the largest degree among these all terms. So 6 will be the largest number. So the degree of the polynomial will be 6. Thanks for watching this video with me. Don't forget to like, share, and subscribe for more math hacks and tips. Until next time, happy mathing!